Yo, what's going on guys? Tanmay here for Simple Snippets and welcome back to another video tutorial on data structures and algorithms. And today's topic is going to be Infix to Postfix Conversion and vice versa. And we're going to do it manually without using stacks, so it's going to be pen and paper calculation. So I'd suggest that you take a pen and paper and we'll solve three examples each. That is, first we'll solve 3 examples of Infix to Postfix and then we'll solve 3 examples of Postfix to Infix for the best practice. And with that being said, let's get started. If you're new to my channel, my name is Tanmay Sakpal and I do a lot of computer science and information technology video tutorials like computer programming, development, technology talks and a lot more on this channel. So if that's something you're interested into, then definitely subscribe and turn on the notifications to get the latest updates and never miss out on such important topics. Okay, so before we start off, if you don't know what is infix, what is prefix, what is postfix expressions, I've discussed it extensively in this course, in this DSA course. So I'll drop the link of this playlist in the video description. Do check it out and watch that video and then you can come back over here. So starting off, we'll convert infix to postfix expression, and as you can see, we've been given 3 steps. Step number 1, 2 and 3. And over here on the right, we have question number 1. We have to convert the following infix expression to postfix expression. Now infix expression is where the operator comes in between the 2 operands. So for minus operator, we have a and b as the 2 operands. For plus operator, we have a minus b as operand 1 and c as operand 2. So we'll understand how that goes in a minute. But let's quickly go ahead and start with the conversion of infix to postfix on question number 1 and by following these steps. Okay. So step number 1 is apply appropriate brackets and parentheses to expressions by following the operator precedence and associativity rules. Now we've already discussed these operator precedence and associativity rules when we took an introduction to infix, prefix and postfix expressions extensively, so do watch that video. But if you're here right now, over here you can see I've already mentioned the operator precedence and associativity rules, and basically they are needed when we are dealing with infix expressions, because in infix expressions things can get a little confusing, things can get a little ambiguous as to which operation happens first in an expression and which happens next or after that operation. So that order of operations is defined by this operator precedence, where parentheses comes first, exponents come second, multiplication and division comes third, and if we have multiplication and division simultaneously, then we have associativity rule where we go from left to right, and at the last precedence level, last priority, we have addition and subtraction, and if we have both addition and subtraction, we go left to right, and which we are going to apply over here also. So step number 1, apply appropriate brackets to expression by following operator precedence and associativity rules. So when you're taking this example, question number 1, we have a minus b plus c. Okay. So we have minus operator and we have plus operator. Now if you see the operator precedence number 4 or priority number 4 is for addition and subtraction. Addition and subtraction have same priority, same precedence. So in that case, you have to go from left to right. So whichever operator is on the left, that happens first. So minus will happen first. And for minus, the 2 operands are a and b. Remember, this is an infix expression. So operator will be having one operator to the left and one operator to the right. And we are talking about binary operators, which means every operator will be operating on 2 operands. So applying the brackets here, the first set of brackets will be something like this, because minus happens first starting from left to right. And whatever result we get from a minus b, let's say it is r1, will be added with c. And that's how the evaluation goes. But right now we are not dealing with evaluation, we are dealing with conversion of infix to postfix. So right now we'll just apply the brackets, and that's step number 1. So larger bracket would be this one and this one. So a minus b is the inner bracket which happens first. After that, whatever result we get from a minus b will be added with c. That's why the square bracket is the larger bracket. Okay. So step number 1 is done. Step number 2 says start by converting the innermost sub expression to postfix and name it with temporary placeholders. So the innermost sub expression that has to be converted first is a minus b, right? So we will convert a minus b to its postfix format. So the postfix format of a minus b would be a, b, and then we have minus, right? So this is postfix format, and then plus c will remain as it is. Let's keep plus c as it is. What we'll do now is, in the step number 2, it is said that we have to convert the sub expression to postfix and name it with a temporary placeholder. So what we'll do, we'll say ab minus can be called as x1. So we are substituting AB minus with a temporary placeholder variable x1. So this equation will look like x1 plus c. Okay. Now further we have to also apply these same steps for this expression also, because x1 plus c is an infix expression right now. So step number 3 says repeat step 2 on larger sub-expressions till the full expression is solved, and lastly resubstitute the temporary placeholders with their original values. So right now we have to again convert x1 plus c into a postfix format. So this is infix. What would be the postfix? Over here the operator is plus. For plus operator, the two operands are x1 and c. So this plus operator comes over here. So we will have x1 c and plus will come over here. So now we have pretty much arrived at the result, but if you see, x1 is actually AB minus. So we have to resubstitute the value of x1 over here, and ultimately we will be getting AB minus, which is the value of x1. You can see over here. So at the place of x1 we are substituting AB minus, and then we also have C plus, right? So this part is left out, so we'll write it as it is. We have C plus. So this basically is the postfix version of this infix version or infix expression. Okay. So final answer would be AB minus C and plus. Okay. So this was question number 1. Let's take question number 2 and further enhance our practice. I hope you have taken a pen and paper and doing these calculations along with me. That's the best way you can practice this. Okay, so here's the second question. Convert the following infix expression to postfix. Again, we're going to follow the same steps. Step number 1, 2 and 3. Step number 1 says apply appropriate brackets and parentheses to expressions by following operator precedence and associativity rules. So let's scan this infix expression. Over here we have a plus operator, we have a multiplication operator, we have a subtraction operator, and we also have a division operator. Now, according to the operator precedence, multiplication and division has higher priority than addition and subtraction. We have all of these involved over here. We have addition, we have subtraction, we have multiplication and division. So multiplication and division obviously are going to happen first. So what we'll do over here is we'll come to multiplication operator, and since this is an infix expression, the two operands for this multiplication operator is B and C, right? So what we'll do, we'll draw brackets over here, that is around B star C. Similarly, for this division operator, the two operands are D and E, right? Because in infix, operator comes in between and the two operands are to the left and right of that operator, especially when we are dealing with binary operators. So again, we'll wrap this in round brackets, and let's just first resolve these two, and then later on we'll add more brackets, or later on we'll convert the plus and minus also. Let's first deal with B star C and D divided by E. Now again, when we have both multiplication and division, we go from left to right. So first we'll solve B star C, and the expression can now be written as A plus, we'll keep A and plus as it is. Let's convert B star C to postfix. So star will come ahead of C. So this equation will become BC and star, right? This is how the postfix version looks like. Then we have a minus in between. And now let's convert D divided by E into postfix. So it would be DE, and then the division operator comes ahead of E. It goes ahead, right? Okay. So we've done two conversions. What we'll do is we'll say BC star. Let's consider BC star as x1, and let's consider DE divided by as x2. So let's replace these temporary variables in these brackets. So then we get the expression as A plus, we have BC star can be replaced by x1. We have a minus operator, and then DE divided by can be replaced by x2. So now you can see we have a simplified format. Now again, we will repeat the step number 2 on other larger sub expressions, because we still have to convert this plus operator and minus operator into its appropriate postfix format, because right now it is still in infix format. So repeat step 2 for other larger sub expressions till the full expression is solved, and then resubstitute the temporary placeholders. So now if you see, we have plus operator and minus operator. Both of them have same precedence, addition and subtraction, but when they have same precedence, we go from left to right. So A plus x1 will be resolved first. So we can add brackets over here. So let's resolve A plus x1, and let's convert this infix expression to postfix expression. So ultimately we will be getting A x1, and this plus operator will go ahead of x1. So you'll get plus over here. We have this minus x2 as it is. And now what we can do, we can say a x1 plus, let me use yellow color. We'll consider a x1 plus as x3. So now the expression will become x3 minus x2. So this is minus, and this is the last conversion left because we still have an infix expression where the operator is in between the two operands x3 and x2. So now ultimately we will get last expression as x3, x2, and minus will come over here. So we've pretty much arrived at our solution, but what we have to do is we have to now resubstitute the temporary placeholders with their original values. So now we will get this expression is x3 and x2. What is x3 value? x3 is a x1 plus. So I have replaced x3 with a x1 plus. And what is x2? x2 is de divided by. So I'll write de divided by over here. Now this expression is still not resolved. We still have one more temporary variable x1. What is the value of x1? x1 is bc star. So let's replace bc star at this place. So ultimately we will get the final answer as a, and at the place of x1 we will replace bc star. So we will get bc star. Then we have a plus over here. So I'll write plus. Then we have de and divide by. So this, my friends, is the final answer. And this is the final postfix version of this infix format. Now the reason why we are using these temporary variables is because it becomes easier to solve them if the expression is large and it's a bit complex. Because if you see over here, when we convert this b star c into its postfix format of bc star, and when we replace bc star with x1, this equation or this expression becomes easier to deal with, right? So later on we can easily resubstitute x1 with its original value of bc star in the final output. So that's why we replace or substitute with simple variables. So these complicated expressions can be denoted by simple temporary variables, which makes it easier to further calculate and further convert the expressions into their appropriate formats. So you can obviously skip this part. You don't need to always use these temporary variables, and you can completely skip the substitution process. But then that will be a little tedious if you're dealing with larger expressions like this one, and if you're a beginner you might make some mistakes. So better substitute them with smaller single variables and then apply the conversion again over them, and ultimately when you get the final result, just resubstitute the original values back and you'll get the final answer. Okay, so this was question number 2. Let's see question number 3. Okay, so here's another infix expression. We have a plus b raised to c. So this caret sign is basically b raised to c. Okay, then we have closing brackets. So we have explicit opening and closing brackets, which means a plus b raised to c happens first, and it is given in the question. So it can be given in question itself where some brackets are already added, and that would mean that that particular part of the expression has to be evaluated first or converted first, basically in our case. So we have a star later on after the brackets, and we have d plus e. Okay, so let's start by converting and applying these steps on this bracket first. So in this bracket we have two operators. We have plus and we have a raised to operator or exponent operator. Now if you see the operator precedence, exponents, that is a raised to b and these caret sign, has much higher value than addition. So it is at position second or precedence second, and addition is at priority 4 or precedence 4. So we will first convert or add brackets over here. That is, inside these already existing brackets, we will first convert b raised to c to its postfix format. So this equation will look like a plus, then we have bc and raised to sign, because in postfix the operator comes ahead of the two operands. Then close this bracket. We have star, we have d, and we have e. Now we can again consider bc raised to as x1. So now this expression will become a plus x1 star d, and there is a plus in between, plus e. Okay, now in the question these are the brackets that were given. So a plus x1 has to happen first rather than this multiplication operator, because as you can see, parenthesis has the highest preference. So a plus x1 needs to be converted to proper postfix format. So that would be a x1 and plus will come over here, and then we have star d plus e. Now again, ax1 plus can be replaced by x2. So we'll write x2 over here. Then we have star d plus e. Now obviously in this expression, we have two operators now. Star operator, that is multiplication, and plus. So obviously x2 star d happens first. So when we convert it to postfix, I'll directly write over here. We will get x2d star, and then we have plus e as it is. So that I'll write in blue. Now let's not substitute x2d star into some other temporary variable. Let's directly evaluate this. We have plus. So this is one operand, and this is another operand for this plus operator. So this plus comes ahead. So we will be getting x2d star e, and then we have plus. So now the only thing left is to resubstitute x2 value. What is x2? We have ax1. So at x2's place, I'm gonna write ax1. Then we have d star e plus, and lastly we have to resubstitute x1's value. What is x1's value? It is bc raised to. So ultimately we are getting a. Then we have bc raised to sign, which is actually the value of x1. Then we have d star e and plus. And this is the final output or result of the conversion of this infix expression to its corresponding postfix format. Okay, so these were the three different examples, and I hope you've got a good practice and these steps are very clear to you. You can Google some more examples. If you want, you can let me know in the comments whether you want some more examples. I can probably share some links where you can practice some more. This is how you manually convert an infix expression to postfix without using stack. We'll obviously see the example where we will use the stack data structure to make these conversions happen, because ultimately it is an application of stack data structure, that is these conversions. But for now we are just understanding how you can do the conversions manually. And now let's move on to the vice versa process, that is how to convert a postfix expression to infix expression. Okay, so we just did the infix to postfix, and now we are doing the reverse process, that is we have to convert a postfix expression to the infix expression. So over here in the question you can see convert the following postfix expression to its infix format. We've been given a postfix expression, and the steps involved are, first we have to start from right to left. So we already did prefix to infix in the previous tutorial. There we were starting from left to right. Over here we are going to start from right to left, that is in this order, and we will keep moving till we get the first instance of one operator followed by two operands. So we should have one operator followed by two operands. Over here plus, and then when we go two more characters ahead, are these two characters operands? No. Over here this is another operator, right? This is an operand. So you can say operand 1, but this is not an operand, it is an operator. So we again move forward. So we come over here, this is an operand, so we are not involved with this. Then we come over here and we see this is one operator, and after this the two elements are operands. So A and B are operands and this is an operator. So this is the ideal situation over here. Start from right to left till you get first instance of one operator. So this is one operator, and these are the two operands which are following minus in right to left direction. So now we have to convert that to infix notation and substitute it with a temporary variable. So what we did, we went from right to left and we came at this operator, and we saw that after this operator we have two operands B and A. So step number 2 says just convert it to infix. So ultimately we have to convert this smaller sub expression into infix format. So it is in postfix right now, and when we convert it to infix, this operator will come in between these two, right? So ultimately the result will be A minus B, because minus will come in between A and B in the infix version, and the remaining thing will be as it is. C plus will be as it is. And in step number 2 we also have to convert it to infix notation and assume or substitute it with a temporary variable. So again A minus B will consider as x1. So this expression will become x1, C and plus. So let's move on to step 3. Step 3 is proceed forward from there to the left or end. That is completely scan this entire expression from right to left and start again and again if end of the expression is arrived, and perform step number 2 again. till the entire expression is converted to its proper infix format. So again we'll start from right to left. We see that we have one operator. Is this operator followed by two operands from right to left? So we'll see this, and you can see these two are operands now because x1 resembles a minus b. So an operand can also be a sub expression, right? So now we have to convert this again to infix. So we'll get plus over here in between, and ultimately we'll get x1 plus c. And now we have pretty much arrived at our solution. So now we just have to resubstitute x1's value, which is a minus b. So instead of x1, I'm gonna write a minus b, and then we have plus c. And this is the proper infix format of this postfix expression. Okay, so this was question number 1, and if you are a little confused, let's see question number 2 for better practice and understanding, and things will be very clear there. Okay, so here's question number 2, and it says convert the following postfix expression to the infix format. So this time we have a little larger expression. So again we'll start from right to left, that is step number 1, start from right to left till you get the first instance of one operator followed by two operands. So we'll start with this operator. Is it followed by two operands? No, because we have one more operator over here. So we'll move forward. Now we'll take this divide operator. Is it followed by two operands? Yes, we have D and E. So after divide by operator, we have two operands. So step number 2 says convert that to infix notation and assume and substitute it with a temporary variable. So when we convert this, we get D by E, because in infix format, the operator comes in between the two operands, right? So let's write it as it is, and we have to substitute D by E as x1. Let's assume it as x1. Let's move forward. Then we have plus operator. Is it followed by two operands? No, we have star over here. So we move forward. Then we see star operator. Is it followed by two operands? Yes, we have C and B. So after star operator, we have C and B. So you have to convert that to infix format. So star will come in between. So after conversion, we will get B star C. And again, we'll assume B star C as x2. Then we'll move forward. We only have one operand left. So in one sweep from right to left, we did two conversions, and the remaining things will be as it is. So A will be as it is, we will have plus as it is, and we will have minus as it is. So ultimately when we substitute B star C to x2 and D by E as x1, we will get A, B star C is x2, then we have a plus operator, then D by E is become x1. So I'll write x1, and then we have a minus operator. Okay. So again, proceed forward from there to the left or end, which means after one sweep we reach the end, and then we start again and we scan again with all the operators. So we'll start from right to left. So over here we have a minus operator. Is minus operator followed by two operands? No, because x1 is there one operand, but then we have one operator, that is plus. So we move forward. Then we see this plus operator. After plus operator, we can see that there are two operands x2 and a. So then we convert this to infix format. So ultimately we are left with a plus x2, and x1 is as it is, and we have minus. So a plus x2 can now be converted to x3 or considered as x3. So we have x3, x1, and we have minus operator. So lastly minus operator is left. After minus operator, do we have two operands? We have x1 and x3. So we convert this to infix by taking minus in between, and ultimately we reach to x3 minus x1. Now the only thing left out is to resubstitute these values of x3, x1 and x2. So x3 is a plus x2, right? What is the value of x3? It is a plus x2. Then we have a minus over here, so we have minus. And what is the value of x1? x1 is d by e. We still have to resubstitute x2's value. What is x2's value? It is b star c. So ultimately we will be left with a plus, then we have b star c, then we have minus d divided by e. And this is the final answer, which is in proper infix format from this postfix expression. Okay, so I hope you've understood now clearly of how to convert postfix to infix. We simply have to scan the entire expression from right to left, and we have to find out a pattern where we get one operator followed by two operands, And as soon as we get that, we have to convert it to infix and substitute it with a temporary variable and then move again to the left. And you have to keep doing it till we get the final answer, till we get all the infix version of the entire postfix expression, and that's how you reach your final answer. So let's take one last example so that this idea is very clear. Okay, so here's another postfix expression, a b c raised to plus d star e plus, and you have to convert it to infix. So we'll start from right to left. We'll see plus, is it followed by two operands? No, we have e, but we have one more operator over here. So we'll go ahead. We'll see this star, is it followed by two operands? We have d, but we have one more plus over here. So no. So even this is not resolved. Then we see plus has one more operator over here, that is raised to. So this is also not resolved. But when you see this raised to sign, this caret, after this caret we have c and b, that is two operands. So you have to convert this to infix. So caret comes in between. So everything else will be as it is. We have a, and then we have b raised to c, and everything else is as it is. And we have to substitute b raised to c as x1. So this equation will now become a, then we have x1 plus d star e plus. Okay, so again we have to go from right to left. If you observe, after this plus sign, now we have two operands, x1 and a. The remaining operators do not follow two operands. So plus, after this plus, we do not have two operands. After this star, we do not have two operands. So that pattern only exists for this particular plus sign over here. So we'll convert this to infix. We will get a plus x1, because plus sign comes in between in infix format, and rest things remain as it is, that is d star en plus. Then we assume a plus x1 as x2. So we get x2 d star e and plus. So again, when we scan from right to left, we can see that after star we have d and x2, that is two operands. So star comes in between. Then we say x2 star d, so convert it to infix, and remaining e plus is kept as it is. Then we substitute x2 star d as x3. So we have x3 e plus. So ultimately this plus operator is left, followed by two operands e and x3. So we get x3 plus e. So we've arrived at our result. Now we just have to resubstitute the values. So x3 is x2 star d. So we get x2 star d in place of x3, and then we have plus e as it is. What is the value of x2? x2 is a plus x1. So we get a plus x1 in the place of x2. Remaining star d plus e is as it is. And lastly, after substituting x1's value, that is b raised to c, we get the final answer of a plus, at the place of x1 we substitute b raised to c. We have b raised to c, and then we have star, we have d plus e. And this is the final infix format of this postfix expression. Okay, so this was the last example of postfix to infix conversion, and by now I'm assuming you guys are having a good hang of it. You can, as I mentioned, practice more examples, try to convert them manually, take a pen and paper. That's the best way you can practice. And I hope this video was understandable. If you like this video, please give this video a thumbs up. Let me know in the comments how this video was. Do share it with your friends, and in further video tutorials now we will see these same conversions using the stacked data structure. So stay tuned for that. Those videos will also be there in this playlist itself. So with that being said, I'm gonna wrap this video over here. Thanks for watching. See you in the next one. Peace.